Hello there. Here we are to continue solving our model exam. The first question here, it says for n by n square matrix. It's a square matrix. Consider it is a square matrix. A, which one of the following is not true? First one, if A is invertible matrix, then the inverse of the inverse is equal to A. That is true. If you inverse the inverse of the inverse will be the original matrix. That's correct. B, for any non-zero scalar k, k times A, the whole inverse is the same as 1 over k times A inverse. Obvious, because this -1, the inverse of, k the power of -1 means 1 over k, so that it will be the same. The third, C, it says if A is an invertible, then the determinant of A and the determinant of the inverse are the same. No. Determinant of a matrix and its inverse are not the same. The determinant of a given matrix, a given square matrix, if it is invertible, and the determinant of its inverse, they are not the same as a rule. But the determinant of a given matrix and its transpose, that's the determinant of the transpose, will be the same. So the answer will be C, because which one is not true, it says. The next one, it says f of x is equal to ln x over x square. Then what is asked, which one of the following is f derivative of x? We are going to apply quotient rule here. So f derivative of x will be the upper derivative times the down as it is minus the upper as it is, you will take it, then times the lower derivative, the whole over what to do, the square of the lower one, x square square. Remember the formula, f over g, the whole derivative means it is the same as f derivative g minus fg derivative over g square. So we can consider ln x as f and this one as g. So I apply that rule here. So let us finish it. So f derivative of x will be ln x derivative, it's 1 over x. The derivative of ln x, it is the same as 1 over x. Ln x derivative, it will be 1 over x. Don't forget this. Therefore, 1 over x times x square will be, just x remain, minus. Here x square derivative is 2x, so we can say 2x ln x. The whole over x to the power of 4. So if you take out x common outside, what remains here? 1 minus 2 times ln x, the whole over x to the power of 4. So now you can cancel 1x here with 1x. This exponent will be 3. So finally the answer will be 1 minus 2 ln x over 3 will be, x cubed. It's going to be 1 minus 2 ln x, the whole over x cubed will remain. So the answer will be A. Next one, f of x is equal to ln x. So what is f derivative at 1? First of all, we have to derive. But here there are two functions composed. First one ln, then the inner function. Even then the inner function by itself, it's a quotient function, and at the same time chain rule it need. So let us see. The derivative of x means, first we have to derive the ln. What is the derivative of ln? 1 over of what? The whole thing. That is x over square root of x square plus 2. Because ln of function, if you have, when you derive it, it will be 1 over the function first. Then you are going to apply chain rule. The inner derivative will continue. But what does this mean? This means I'm going to flip 1 over, this thing means 1 over, like 1 over 3 over 4. If you have, what does this mean? It's the same as 3 over 4. 4 over 3. You are going to flip the down fraction. So let us apply that rule here. The denominator will be numerator. So I can write it is the same as square root of x square plus 2 the whole over x times, I'm going to derivate again the derivative of what? X over square root of x square plus 2. This derivative. What is the derivative of this function? X over x square plus 2 in the radical. X over x square plus 2 in the radical. When you derivate this one, it is the same as the upper derivative, that is 1 times the lower one as it is, x square plus 2, you will take it, minus the upper as it is times the lower derivative. What's the derivative of this? It's going to be 1 over 2 times square root of x square plus 2, again times by chain rule the inner derivative, which is 2x. I have to complete it here. The whole over the square of this one. I'm going to square it. That means square root of x square plus 2. When you square it, the radical will be removed, you know. So this radical will be removed by the square. Here again 2 cancel with 2, and then crisscross. When you multiply crisscross, you'll multiply the 2 and the square root cancelled out, and what remain? X square plus 2 remain, minus x times x will be x square, the whole over what left? This thing left, square root of x square plus 2, x square plus 2 times, again this is going to be flipped and multiplied. Here it is, x square plus 2 will come here. What did I do? First of all, I try to finalize this whole, the upper part, this one. How? The 2 cancelled, and x times x will be x square times, by crisscross I did it, so 2 product, here it is, and 1 times x square, here it is. Then what is in the denominator of, for the upper part, only the square root of x square plus 2 remains, but times I have to flip. This means over 1, you know, the square and the square, I mean the square root and the square cancel already. It was x square plus 2, so when you multiply, here it is. So the final answer here, x square cancel with x square, what left? 2 over square root of x square plus 2 and times x square plus 2, or we can put it in one exponent, but no problem, let's keep it as it is, and let's get back now because we are asked at 1. I'm going to insert 1 now. Therefore this is the whole derivative already derivated. So what do we have? Remember, it is 2 over square root of x square plus 2 times x square plus 2. That means we can cancel x square plus 2 with x square plus 2. So f derivative of x become now 2 over x into x square plus 2. Therefore let us insert now. F derivative at 1 means I'm going to insert now 1. 2 over 1 into 1 plus 2, which is 2 over 3. F derivative at 1 is equal to 2 over 3. So where is the answer found? By the way, this means the whole over. Where is it? The answer 2 over 3. It's not in the choice, but look the choice C. Just for confusion purpose, ln e is written, but ln e means it's 1, you know. Don't forget, ln e means it is the same as logarithm of e to the base e, which is 1. So it doesn't have 1 times 2 over 3 means 2 over 3, so the answer will be C. Next question. So the next question, it is system of linear equation with 4 variables. So it says what should be the value of k so that the system of equation has a solution. So first of all, from the first part here, from the first row here, we can express z is equal to x plus t plus 3. We can shift x to the other side, as you see, x is shifted and the t also, and then we can substitute in place of that everything what we see here, the z value. So we can insert in place of z in the second row, in the third row, and in the fourth row,
and let us condense it. How does it looks? Let us see. So it's going to be, when you are replacing 2x plus 2y minus z in place of z, what is replaced, as you see, x plus t plus 3. It's replaced. Minus 7t is equal to 1. The second also the second equation, in place of 9z we substitute 9 times the z value, what you see here, and then we distribute and condense. We simplified. So when you simplify this one, it's going to be, the constant will be shifted to the other side. So 2x plus 2y minus 8t is equal to 4 comes. This is the first row. This one is the same as this result, and the second row also the same manner, and the third row also the same manner. Now when you try to observe here, the second and the third equation here, they have the same coefficient. The coefficient are the same. 5x is there, there is 5x here also, negative 5x, negative 5x, and negative y, and negative y, and negative 14 and negative 14, they are the same. So if the constant here also the same, everything will be cancelled out, and it's going to be it will have a many solution. In case of argumented matrix, for example, when you are trying to reduce by elementary row echelon form, if the upper comes, for example, 1 0 0, and there is a constant number, let's say a here, and 0 1 0 constant number b, and 0 0 1 constant number c, if it comes in this way, it will be a unique solution, you can say. But one of the last row or one of the middle row cancelled out, means totally everything. If it is 0, even the constant, that means the given system of linear equation will have many solutions. Otherwise, if every coefficient, what you see here, the coefficient matrix, means this part, the coefficient matrix, if everything becomes 0, one of the row, if it becomes 0, and if the constant is not 0, it will not have solution. But this one, the equation says it has a solution. So to have a solution, as you see the coefficient, it's going to be 0 if you add the coefficient, or if you subtract. If you subtract, one of the row is going to be 0, the coefficient matrix. But the constant, is it going to be 0? Yes, it will be if they are the same. K plus 27, if it is equal to 25, this one, it must be 25. Let's correct it. This must be 25, because when you simplify it, you can check it out. Because negative 24 plus 1, when you shift it, it will be plus 1, so it will be 25. So to have a solution, everything one of the row, everything must be 0. So to make it 0, the coefficient already, as you see, everything is constant. So we have to make the two equal to have a solution. Therefore, let us do it. It's going to be k plus 27. It must be equal to 25. When you shift the 27 to the other side, k must be negative 2. So to have a solution, or to say this system of linear equation have a solution, the k value must be negative 2. Otherwise, if k is not negative 2, this system of linear equation will not have a solution. That means if the constant here, this constant, and if this constant, if they are not equal, the system of linear equation will not have a solution, because everything constant, as you see, they are the same. If you subtract, everything cancel out, but the constant will be different. It doesn't work. By row reduction method, you can check that process, somehow longer process, but this is the way how to do. Okay, the last question here, it says, what is the simplified form of 1 plus 2i times I minus 3 plus 2i over, let's write it, 1 plus 2i times I minus 3 plus 2i the whole over 1 minus I. You can rationalize this first. You can multiply by 1 plus I times 1 plus I by the conjugate of the denominator and simplify. What will be the result here? So when you multiply the upper part, it's going to be 3 times, you can process it. 3 will multiply 1 and 3 multiply I, which will be 3 plus 3i. It's going to be, and again the 2 will multiply each of them, that will be 2i minus 2, because 2i times I will be negative 2, so 3i plus 2i will be 5i, I wrote it here, and 3 minus 2 will be 1, I wrote it here. Then the whole, the denominator part, 1 square plus 1 square, which will be just 2. Then again here you have to multiply, this I will multiply each of them when you multiply it, I times 1 will be I, here it is, and I times 2I will be negative 2. Then there is minus here, don't forget, this minus will be for both of them. This denominator you can give for each, so 1 over 2 plus 5 over 2, so the minus will be distributed. And then do the constant together. These are constant, like the real part. So this denominator 1, so negative 2 times 2, you know, negative 4 minus 1, negative 5 over 2. It will be negative 5 over 2. This is the real part. And then the imaginary parts are these two, this one and this one. So the denominator, this is 1, so I times 2 will be 2i, and negative 5 times 1 will be negative 5i, which will be negative 3i over 2. You know, the denominator will be the same. So minus 3 over 2i. That's going to be the final answer. So these are the way how we can solve some of the questions. I'll get back to another video. Thank you for watching. Don't forget to subscribe, like, and share to your friends.